Hi, sixth graders, this is Mrs. Gall. Today we're going to start our data unit. Open up your notebook to a fresh page and press play when you're ready to continue. This lesson is going to be talking about 3 different types of skills. The first skill we're going to talk through is statistical questions. Let's take a look at a list of statistical questions and a list of non-statistical questions. Pause the video. What are you noticing as you compare the 2 columns? Let's think about what some of the characteristics are for these questions that are on the statistical question side. There's 4 things that a statistical question has. Let's see if you were able to spot any of them. The first thing is all of the answers must be numerical. That means we get a number answer when we ask it. The second thing is that a statistical question must have a variety of answers. We don't just want one answer or 2 answers. We want to have the possibility to have a variety. We want to specify and ask a group of people or maybe things. And then maybe you notice that the word average or typical showed up in a lot of those statistical questions on the last page. And it just usually has to have that. That is not a must. But a statistical question must have these top 3 things. Pause the video and write that down now if you don't already have it down. Let's look at an example. How long does it take the average Waukee Middle School student to get home from school? This question is statistical because it has all of these 4 things. We would get a numerical answer because we're measuring how long it takes, which would be time. We would get a variety of answers because each student, it's going to take a different length of time to get home. We're asking a group. Who would our group be here? Our Waukee Middle School students. And then remember, if we see that word average or typical, it's usually going to be there, but it does not have to be. Here's a non-example. What is your favorite color? Why wouldn't this one work? Well, we're not going to get a numerical answer if we're asking about favorite colors. And notice how we didn't ask a group. We're only asking one person. What is your favorite color? That would only give us one answer. So we want to specify a group that we would be asking about their favorite color. You choose if you think this would be statistical or non-statistical. Who is the quarterback of the Minnesota Vikings? What do you think? That one would be non-statistical because we would get one or maybe a few answers if there's a backup, and it is not a numerical answer. What is the average age when a child loses his or her first tooth? What do you think? That would be statistical. We would get a numerical answer. We would get variety. Although the group child or children is a large group, it's still specifying an age group, so that would be our group. And then we also see that word average in there. Let's practice rewriting a few questions to make them statistical. So here's a non-statistical question. Do you like to play video games? How could we change that to make it a statistical question? Remember, we want to ask something to a group where we would get a numerical answer. A common misconception we'll hear is how many students at WMS like to play video games? Well, what would you go around and ask people? You would just say, do you like to play video games? And they would give you a yes or no answer. That is not numerical data. We want to ask people something about video games where they would reply with a numerical answer. So we could ask them about time, how much time is spent playing video games. That will usually tell us if someone likes to play, if they're spending more time. So we could say, how many minutes does an average 6th grader play video games in a night? We could also ask about how many video games they own. So we could say, how many video games does an average 6th grader own? And that would give us a numerical answer as well. Let's think about data in a statistical question versus data in a non-statistical question, and how might that look differently in a graph? What do you think? Here's an example. On the left, we have the question, what is the average 6th grader's favorite book? What do you notice about those answers? They're all different, and none of them are numerical, so we're getting names of books. And then on the other side, we see how many siblings does a typical sixth grader have. What do you notice there? I notice it's really easy for us to pick out what's a common number of siblings for sixth graders to have, like one or two. We have like 27 and 26 people that have that amount. So it's that numerical data groups together much easier when we're asking a question that requires a numerical answer, rather than when we just get this really long list of all these different books. It's much more challenging to pick out where those trends are happening. What about this one? On the left, we have what is the age of an average sixth grader. Now that's numerical data. Do we have a lot of variety there? No, because most sixth graders are 11 or 12. On the right side, we have how many pencils does a typical sixth grader have in their binder? Do we have more variety with that type of question? Yes, we have a lot more variety. So over on the left, this could be argued as a non-statistical question because it doesn't give us much variety. We know how old a typical sixth grader is going to be, but how many pencils a typical sixth grader has is going to give us much more variety. Let's move on to our second skill of this lesson, which is sample versus population. Let's think about the question, how many minutes does an average sixth grader play video games in a night? Suppose you're investigating this statistical question. Who would you have to go ask this question? Probably a group of sixth graders. How many sixth graders would you have to ask? Do you think 3 would be enough? Probably not. That wouldn't give us enough of data to collect. How would you select which sixth graders you asked? Would you go and ask all your friends who you know like to play video games? Let's think about some of those things. So population versus sample. Population is the whole group that you're thinking about, and sample is a subgroup of the population that represents the whole. The sample is who you're asking your statistical question to. So my population in this question, who is the whole group? The whole group is all sixth graders because we're talking about the average sixth grader. But then we need to figure out who our sample is going to be. Maybe your sample is 30 randomly selected sixth graders. Ooh, why do you think we put the word randomly in there? Because having 30 random sixth graders is going to give you a more unbiased sample, which leads us into our last skill, biased versus unbiased. Thinking about the same question, let's talk about what biased and unbiased means. Biased is a sample not representative of the population. And unbiased is a sample that's representative of the population. Biased means there's something there that might kind of skew our answers. That means lead them in a certain way. Whereas unbiased is representing everyone in our group. A biased example would be if we asked this question to 30 members of the video game club. Why would that be biased? Well, our question is about how long you spend playing video games. Do you think members of a video game club might really enjoy video games and spend a lot of time? They probably would, so that would give us a biased sample. Unbiased would be if we randomly selected 30 sixth graders without preference. That would give us a better view at how many minutes just a typical sixth grader plays video games. So unbiased samples are representative of the larger population. They need to be selected at random or without preference. They're large enough to provide accurate data. And here's some strategies you could use for obtaining a random sample. You could use a computer that randomly selects every 5th or 8th or 10th person. You could go through a list and select by a specific interval, kind of like I said, maybe look at every 5th person, every 8th person. You could divide into small, non-overlapping groups and select a sample from each group. Let's look at an example. Mr. Stevens wanted to know where high school students prefer to vacation. He surveyed every 10th student in line at the cafeteria. Who's our population? Well, Mr. Stevens wants to know where high school students prefer to vacation. So his population would be his group, which is high school students. What is the sample? Who does he actually ask? He actually surveyed every 10th student in line at the cafeteria. So that would be every 10th student in line would be our sample. That's who was actually asked. Is this biased or unbiased to ask every 10th person in line at the cafeteria? This would be unbiased. It is representative, and he randomly selected the sample. He didn't say, oh, I'm going to go ask my 5 people that I know just went on vacation. He randomly said, I'm going to use every 10th person in line, which would provide that good unbiased sample. Let's look at one more example. A radio station wanted to determine the types of music their listeners enjoy, so they surveyed the music genre preference of all the attendees of a country music concert. Who's the population? Well, it's a radio station that wants to know what their listeners enjoy. So that would be the radio station listeners would be the population, the whole group. Who was the actual sample? Who did they survey? They surveyed the attendees of a country music concert. Is that biased or unbiased for a radio station to ask attendees of a country music concert what genre they like? Well, we're only getting people that attended a country music concert. Only country fans were surveyed. So that would actually be a biased group because we didn't choose a group that was random, right? We specified a certain genre that we were asking. We were asking these people that attended the country music concert. So we want to ask a better group that would give us more variety. All right, you guys, that's all I have for you today over statistical questions, population versus sample, and unbiased versus biased. Check in with your teacher if you have any questions.